Hey, fourth graders. This lesson is lesson 4.5. It's on estimating quotients using compatible numbers. We practiced using compatible numbers yesterday. So hopefully this lesson, you'll start comfortable with it as you get used to some of the problems using what you learned yesterday and what you learned today. I'm on page 221, and I'm going to do this page and part of the next page with you. So it says, a horse's heart beats 132 times in 3 minutes. About how many times does it beat in 1 minute? So think, will horse's heart beat more or fewer than 132 times in 1 minute? So we're trying to think, we're going to take these 132 times and divide them evenly between the 3 minutes that they are measuring. So if we're just measuring it for 1 minute, then it's going to be less than. It's going to be fewer than that because it's smaller than the total. Remember, with division, after you divide, your answer is going to be smaller than what you started out with. So it's going to be fewer times, and we're going to use division to figure that out. Now, again, this lesson is all about estimating. You're not going to get exact right answers, and there's not exactly one right way to do it. It's just whatever compatible numbers work to comfortably figure out these problems quickly, which is what an estimation is for. So these compatible numbers are numbers that are easy to compute mentally. So this first one we're going to do 132 divided by 3, which is the problem up here. Step 1, find a number that's close to 132 that divides easily by 3. And we're going to use basic facts to do that. Now, we did this yesterday when we did our compatibility game, but we had 132. If we figure out multiples of 3 that are close to this 13 right here, we're just looking at the first 2 digits for now. So I know multiples of 3 are 3, 6, 9, 12, 15, 18, which I already skipped over 13, but 12 and 15 have 13 in between them. So I know that these are both divisible by 3 easily. I know that 3 divides evenly into 12 and 3 divides evenly into 15. So I'm going to pick the 12 because it's closer to the 13. You can use the 15, but it's going to be a little bit further away of an estimation. So I'm going to use 12. I'm going to replace this with a 12 and make it 120 just for estimating purposes. So we're going to transform this number into 120, which is somewhat close to this just for the sake of estimation. So 120 is the same thing as 12 tens. This is like when we chop off our 0 and we turn it into a 12. It's just like that. 12 divided by 3 is 4. So then I do 12 tens divided by 3 is 4 tens. It's just the same thing, but we're putting our 0 back on. So 120 divided by 3 is 40. So our answer to this problem is going to be about 40 times a minute. Now, if we were to do the division for real, it would be probably a little bit more than 40 because the 132 is a little bit more than the 120, but it's at least an estimate. It gives us a place to start. You can also use the compatible numbers on both sides to estimate what your answer would be between. This uses the same idea as up here. However, you have 2 numbers that you're going to look at instead of just 1. So it says, use compatible numbers to find 2 estimates that the quotient is between 1,382 divided by 5. So again, I'm going to look at these first 2 digits and think what multiples of 5 are somewhat close to 13. So we would have 5, 10, 15, 20. Well, 10 and 15 are on either side of the 13, so I'm going to use 10 and 15. So 10 divided by 5 is a basic fact. We know that that comes out to be 2. And 15 divided by 5 is a basic fact. That's a quick one. We can figure out that's 3. 13 divided by 5, we'd have to do some thinking and divide and have remainders and all of those things. But these are multiples of 5 that are close to 13, but are easily able to divide because of the way 5 fits in with these other numbers. So we know that 1,382 is between 1,000 and 1,500. So what they did here is they took the 1,382 and replaced the first 2 digits with a 10, turned everything else to zeros, and these 2 digits with a 15 and turned it to zeros. because we're estimating. It's kind of like a weird way of rounding. So we're going to do each of these divided by 5. So we have 1,000 divided by 5, which is our estimate on the smaller side of this number. 1,000 is the same thing as 10 hundreds. 10 divided by 5 is 2. 2 hundreds, or 200. So that's going to be our first estimate. But then the 15 estimates over here. 15 divided by 5 is 3. So 15 hundreds divided by 5 is 3 hundreds, or 300. So I know that the answer is going to be between 200 and 300. So that's another way of estimating, is finding your answer is going to be between these somewhere. But I think probably the quickest way is to do compatible numbers with the estimation up here. Find the one that it's closest to and just go with that. This is the same thing as this one. However, they had you do both of these at the same time to find what the answer is between. This one, they gave you both, but then advised you to pick the one that's closest to the original number. And this is what I would really advise you to do too. So you don't have to do twice the work, but this is a way to do it if you feel that way. So turn the page with me. The top one says estimate 1,718, divided by 4. So the same thing, I'm going to look at the first 2 digits of my number and I'm going to think, what multiples of 4 is close to 17? So if I were looking at a multiplication chart, I would get 4, 8, 12, 16, 20. 17 goes somewhere in between these guys, the 16 and the 20. So I'm going to use 16 and 20 for my estimates. Again, we're just trying to find numbers that are close to the original number, that are close to it, that are easy to compute with the number that we were given. So these are numbers that are easy to work with 4, but they're the closest to 17. So we're trying to find the best of both worlds here. So what basic fact can you use? I can use 16 divided by 4, and I can use 20 divided by 4. I'm going to use the 16 because 16 is closer to 17, which is my original number. The 20 is too far off. 20 is 3 away from 17. 16 is only 1 away. So I'm not actually going to use the 20 because it's too far away. I'm going to choose 1600 because it's closest to 17. Because it's closer to the original number. So now I can do 16 divided by 4 and get 4. So if I'm doing that with this, 16 divided by 4, 16, 4 is 4, with my 2 zeros put back on, is 400. So the estimate for 1,718 divided by 4 is about 400. Now, you don't have to go through all of these steps to estimate, but this is all of the thinking that goes in behind it. So what I like to do is I like to think of the multiples of each number and figure out which one's closest to it, and then estimate with the one that's closest to, just like we did with our game. So I've got 455 divided by 9. I'm looking at the first 2 digits. Multiples of 9 are 9, 18, 27, 36, 45. Oh, that's exactly 45. So that's the 5th multiple of 9. That's the 5th number on my list. Again, you don't have to write these down. Use a multiplication chart. I just don't have one with me, so I wrote them down so I have them with me. So I'm going to do 450. Again, I'm just going to use the 45 because the 45 was right on my list. Turn the rest to a 0. Like I said, it's a weird form of rounding. And then I'm going to divide by 9. 45 divided by 9 is 5, with my 1 0 put back on. So the answer to 455 divided by 9 is going to be close to 50. 50 is an estimate. Same thing with this one. I have 15 and 3. I know that 3 times 5 is 15, so I know that that's exactly on my list. So I'm just going to estimate using 1,500, which is 1,500, keeping the 15 and leaving my zeros there. And then I'm going to divide by 3. 15 divided by 3 is 5. With 2 zeros, gives it 2 zeros on here, 500. These two are a little trickier because the first 2 digits of each of the numbers don't exactly fall on the list of multiples. So I've got 17 for this one, but I have 8. So that means I have 8, 16, 24, 32. 17 falls right in between these two. 17 is closer to 16 than it is to 24, so I'm going to use the 16. Replace my 17 with 16, turn the rest to 0, and divide by 8. 16 divided by 8 is 8 with 1 0. So my answer is about 80. If I did it for real, it would probably be a little bit more than 80 because 176 is a little bit more than 160. But this is an estimate. It gives you an idea. This is closer, this is faster to do than it is to actually sit down there and divide each of these by hand. Okay? And then the last one, I've got 2,700, but 2,795 divided by 7. 27's in my beginning here. So my multiples of 7 are 7, 14, 21, 28. 27 falls between 21 and 28, but it's closer to 28 than it is to 21, so I'm going to use the 28. 28 divided by 7 is 4, with 2 zeros, makes it 400. So my answer is going to be close to 400. If you have any questions about this, let me know. We'll talk about it more in class when I see you. Bye.